the car parked on a hill overnight. So we'll start out with the free body diagram. I will draw a little hill just to give us some context for what this is going to look like. And then for our car, gravity always goes down, normal force perpendicular, and in this case, since it's not falling down the hill yet, we have force of friction. When the car is sliding down the hill, it's going to look essentially the same with gravity, normal, and less friction. We don't really know how much less yet, but we'll work it out. We're also going to point out that the coordinate system for this is going to change. We're going to call the horizontal axis parallel to the plane, and the vertical axis, the y-axis, is perpendicular to the plane. So that way, the direction it's going is the positive x-axis. Writing out our equations. So horizontally, we have force of friction, and with this new coordinate system, we're going to have a component of gravity acting in the y and a component of it acting in the x. So we'll also have this force of gravity in the x. And vertically will be the same thing, but we'll have our normal force and our force of gravity in the y. We're going to make that down direction negative and friction negative. As the car slides down the hill, we'll write those two equations to be roughly the same thing: force of friction and force of gravity in the x, and in the y it'll be normal force and force of gravity in the y. The minimum coefficient before the car can slid down the hill. Okay, so we're going to have to do a couple things to come up with first force of gravity in the x. So in the x component, this is our angle, which is the same angle as the hill, which is 20 degrees. And we're looking at, for x, the opposite side. So it'll be sine of 20 times what the force of gravity would ordinarily be, which is mass times gravity. And if you work those numbers, force of gravity in the x should be 342. Force of gravity in the y should be cosine of 20 times mass gravity, and I have that as about 9,210 newtons. Boom. So for minimum coefficient of friction, in order for that to happen, going back up to this equation, that means net force is 0. If the force of gravity x is 342, the force of friction has to be 342. Net force in the y is 0. If the force of gravity in the y is 9,210, the normal force is 9,210. This is negative, and all of that math should work out. That's why we do those equations, is to keep it clear. So now, if I want a coefficient, it is simply our force of friction divided by the normal force, and I've got those two up above. 342 divided by 9,210, and I get about 0.037 as that coefficient. Okay, the car accelerating down the hill now. I've got the information up there. It reaches a velocity of 1 meter per second in 10 seconds. So 1 over 10 is also known as a tenth. So the acceleration will be 0.01 meter per second per second. What is the net force as the car slides down the hill? So net force, the sum of those forces is always that mass accelerating. The mass is 1,000. The acceleration is 0.1. So our net force will be just 100 newtons. What is the coefficient of friction as it rolls down the hill? So now, that's why we have this second set of equations. We'll write the net force as 100. Force of gravity is still 342, but if our net force is 100, our force of friction is just dropped to 242 in order for this map to work out. Nothing has changed vertically. So now what I can write will be something like force of friction. The coefficient is going to be that force of friction over normal again, but now our force of friction is 242 over the normal force of 9,210. Just erase that. 9,210, and that works out to about 0.026. Boom, something like that. All right, good luck.